Assalamualaikum. Let's continue with the General Foundry Project Network. Now, we have seen that the project is expected to complete on the 15 weeks. And the manager thinks that it is quite risky because they are given 16 weeks to complete the project. Why is it quite risky? Because the probability of completing the project in 15 weeks is 50-50, it's 50%. So there's 50% chance that the project will not be completed in 15 weeks. So it's quite risky. Therefore, the manager wants to shorten the amount of time the project can be completed. We call this crashing the project to 14 weeks. Okay, so before we can start, we have to get some information on the cost of crashing, the normal cost and the crash cost. So as we can see, this information were obtained by the manager. So each activity are listed here, A, B, C, D, E, F, G, H. And these are the normal time taken, which we have seen how to calculate. This is the estimated time of each activity. Now this is the fastest time. The crash time in weeks is the fastest time. That means normally A can be done in 2 weeks, but it can be shortened to 1 week. So which is called the crash time. So same thing with B. Normally it can be completed in 3 weeks, but it can be shortened to only 1 week. Okay, so similarly for the rest. Now these are the costs. Normally in 2 weeks, it will take 22,000 to complete A in 2 weeks. But to complete A in 1 week, it will take 23,000. That means an increase of 1,000. So the crash cost for 1 week, because the time is reduced only 1 week, is 1,000. So this is called the crash cost per week. Now, is A critical? Yes, it is on the critical path. It is one of the critical activities. Now let's look at B. B normally takes 3 weeks. It can be shortened to 1 week. That means it can be reduced by 2 weeks. The normal cost for 3 weeks is 30,000. But if we reduce by 2 weeks, then the cost will go up to 34,000. That means the crash cost per week will be 2,000, which is 4,000 divided by the amount of weeks reduced, which is 2 weeks. Okay, so 4,000 divided by 2, we get 2,000. And B is not critical. Now C is reduced by only 1 week, increase of 1,000. So crash cost per week is 1,000. Now what about D? D reduces by 1 week, from 48,000 to 49,000. That means increase of 1,000. So the crash cost per week is 1,000. And then E can be shortened to only 2 weeks. Now the increase in cost will be 2,000, from 56 to 58,000. Therefore the cost per week is 1,000. The crash cost per week is 1,000. Now activity F can be reduced to 2 weeks. That means a reduction of 1 week, and the cost increased by 500. So the crash cost per week is 500. Is it critical? No. Now G normally takes 5 weeks, can be shortened to 2 weeks. That means a reduction of 3 weeks, and the cost will increase by 6,000. So 6,000 divided by 3, that will be 2,000 per week. The crash cost is 2,000 per week. Now H normally takes 2 weeks, can be reduced by 1 week to 1 week, and the increase is 3,000. So the crash cost per week is 3,000. Is H critical? Yes. Okay. Now to crash the cost, we have to look at the activities on the critical path. Okay, so let me show you this diagram here. We have the path. Okay, the path is ACFH, ACEGH, BDGH. Now where do I get this path? Let me show you where I got the paths. You can see here, remember this diagram? Alright, we have how many paths here? We have this path, alright, finished. And then we have this path. Can you see that? Alright, and then we have this path. Okay, so the first path is ACFH, okay, and the second path is ACEGH, right, and finished. And then the third path is BDGH. Okay, so this is how I got these three paths. Now if we add the time for each activity in the path, we can see that ACFH, so 2 plus 2 plus 3 plus 2, that should be 9. Okay, sorry, this should be 9. This should be 9 weeks. And then ACEGH is 2 plus 2, 4 plus 4, 8, 8 plus 5, 13, plus 2, 15. Okay, so 15. And this is the longest time path, so it is the critical path. And then BDGH, 3 plus 4, 7, plus 5, 12, plus 2, 14. So it is 14 weeks. Okay, now if we look at these paths, the critical path is the middle path, alright. This is the path that we are going to crash. Okay, there's no point in crashing the other paths, because if we crash this path, for example, by 1 week to 13 weeks, the project will still be completed in 15 weeks, because this path has to be completed to finish the project. So we have to reduce the critical path by 1 week. Okay, if we look at the crash course, we can see that the minimum cost is activity A, activity C, and activity E. So we can crash either A, C, or E because they have the same minimum cost, crash cost per week. So let's say we want to crash E for 1 week, then the duration of the path will be like this. Okay, okay, again I made this mistake. ACFH should be 9 weeks. Now ACEGH now becomes 14 weeks because we have minus 1 week from E, and then BDGH becomes 14 weeks. BDGH is already 14 weeks as it is. Okay, so now these two are the critical paths, and the project will be completed in 14 weeks. So we can stop here because we have already obtained 14 weeks duration of the project. Now we're going to calculate the cost. So by crashing E by 1 week, we have an additional cost of 1,000. So the total cost to complete the project in 14 weeks will be the total normal cost plus the crash cost. Now the total normal cost is the total of this cost, which is 308,000, plus the crash cost will be 309,000. Okay, so that's it for crashing.